Good evening. Let us revise the concept of an important concept rather of left hand and right hand limits. When we say x tends to a, or we will consider one particular case. Suppose we say x tends to 2. So there are two possibilities. Possibility number 1, x approaches 2 from the right of 2. Okay, tending value is 2 only, but it approaches 2 from the right of 2. So limit obtained in this case is called as right hand limit, and we write this as limit extends to 2 plus. Okay, now second possibility, approaching value is 2 only, but x approaches 2 from the left of 2. So in this case, the limit obtained is called as left hand limit, and we write this as limit extends to 2 minus. Please remember, 2 minus does not mean minus 2. 2 minus means tending value is 2 only. The only thing is it approaches 2 from the left of 2. Clearly, if limit has to exist, it should exist uniquely. And therefore, what is the criterion for existence of limit? Limit extends to 2 minus fx must be the same as limit extends to 2 plus fx. Then only we say that limit extends to 2fx exists. Now, same question again. How can we know whether left hand and right hand limits are to be obtained or not? Because in all the sums which we have solved up till now, we never used this concept. The logic is simple. When you are given piecewise function, we have to go for left hand and right hand limits. Of course, there are some functions like step function or modulus function. In such cases also, we have to go for left hand and right hand limits. Yes, second part first sum, just listen to me. You have to copy the solution afterwards, after the lecture. Limit extends to 0, 1 minus x raised to 5 minus 1 upon cube of 1 minus x minus 1. Put 1 minus x equal to h. As x tends to 0, h will tend to 1. So this becomes limit h tends to 1, h raised to 5 minus 1 upon h cube minus 1. Divide numerator and denominator by h minus 1. Now which standard limit? Limit extends to a, x raised to n minus a raised to n upon x minus a. It is n raised to n minus 1. It is better if you use the variable h here, because here variable is h. Of course, in standard limit, variable is immaterial. Okay. So this is 5 into 1 raised to 5 minus 1 upon 3 into 1 raised to 3 minus 1. So what is the final answer? It is 5 upon 3. Second sum, limit of step function x as x tends to 0. Okay. Now, let me explain first. See, step x is 0 if 0 less than x less than 1. See, when we say x tends to 2, it may approach, I'm sorry, when we say x tends to 0, it may approach 0, I'm sorry, from right or from left. And therefore I have written step x equal to 0 if 0 less than x less than 1, and step x is minus 1 when minus 1 less than x less than 0. Why? Because we consider the nearest integer but to the left. Okay, and therefore limit extends to 0 minus fx. 0 minus means to the left of 0, and for that we have to consider which function? This one, minus 1. What is limit of minus 1? Minus 1. Limit extends to 0 plus fx. 0 plus means greater than 0. So to the right of 0, but very close to 0, what is step value? It is nothing but 0. So right hand limit is 0. Note that left hand limit is not the same as right hand limit, and therefore this limit does not exist. Now third sum, if f of r is pi r square, find limit h tends to 0 f of r plus h minus f of r upon h. Now f of r is pi r square. So what is f of r plus h? It is pi into, previously it was square of r, now it is square of r plus h. Simple. Just simplify by opening the brackets. Now substitute. Pi r square gets cancelled. From these two terms, take h common. Can I cancel h? Yes, I can. H only tends to 0, not equal to 0. Take limit. To take the limit means to replace every h by its limiting value, which is 0. So final answer is 2 pi r. Fourth one, limit x tends to 0, x upon mod x plus x square. Uh, I hope you know the concept of modulus. Modulus of x is x when x is non-negative, that is greater than or equal to 0. But when x is negative, means that is x is less than 0. What is mod x? Minus x. Still many students think that x means positive and minus x means negative. No. If I say minus 3, yes, it is definitely negative, right? But if I say just minus a, there are three possibilities actually. Minus a can be negative, minus a can be 0, minus a can be positive also, right? Okay. Now, limit x tends to 0 plus. So for that, what is mod x? X. So this becomes x upon x plus x square. Take x common from denominator, cancel that, take the limit. To take the limit means to replace x by its limiting value, which is 0. So what is the right hand limit? Right hand limit is 1. Now limit x tends to 0 minus fx is limit x tends to 0 minus x upon, what is mod x if x is negative? Minus x plus x square as it is. Take x common from denominator, cancel it. Take the limit now. So what is left hand limit? Minus 1. As limit x tends to 0 minus is not the same as limit x tends to 0 plus. This limit does not exist. Fifth one, find the limit of the function if it exists at x equal to 1 if f of x is 7 minus 4x for x less than 1 equal to x square plus 2 for x greater than or equal to 1. Now to find left hand limit, we must consider x to the left of 1, that is x less than 1. So for that, what is fx? 7 minus 4x. So what is left hand limit? I repeat, x tends to 1 minus does not mean tending value is minus 1. It only means that x approaches 1 from left of 1. And that is why we have chosen this function. Otherwise, we would have chosen the other one. Okay. So take the limit 7 minus 4 into 1. So what is the left hand limit? It is nothing but 3. Also, f of x is x square plus 2 for x greater than or equal to 1. Limit x tends to 1 plus fx is limit x tends to 1 plus x square plus 2. Take the limit, its value is 3. As left hand limit is the same as right hand limit, limit x tends to 1 f of x exists. And we should also mention that its value is nothing but 3. I'll write that. And limit x tends to 1 fx is nothing but 3. Now sum number 6, let me explain. Given 7x less than or equal to fx less than or equal to 3x square minus 6 for all x, determine the value of limit x tends to 3 f of x. Now we are given this. Take the limit. What is limit of 7x as x tends to 3? 21. What about this? 21, right? So 21 less than or equal to limit fx x tends to 3 less than or equal to 21. So by squeezing theorem, what is the value of the limit? It is nothing but 21. Sum number 10, let me explain. You have to write the solution after the lecture. Limit x tends to 0, a raised to 3x minus a raised to 2x minus a raised to x plus 1 upon x tan x. Now many students ask me, sir, how can we know whether adjustment is to be done in the form of adding 1, subtracting 1, etc. The logic is simple. Observe the denominator. It is x tan x. So clearly we need tan x upon x. To get tan x upon x, we'll have to divide by, not by x, but by x square. If you just divide by x, this x will vanish. But we need tan x upon x, right? We cannot just divide denominator by x square. We have to divide numerator also by x square. This means numerator is to be expressed neither as a sum or difference, but as product of two exponential functions. So you should think in that direction, right? Now what is a raised to 3x? A raised to 2x into a raised to x. Take a raised to 2x common to get this. Take minus 1 common from last two terms to get this. Now take this bracket common to get this. See what is difficult? Limits. No, evaluation of limit is in the last step and it is the simplest part. So what is difficult? Factorization and all that. Laws of indices. Okay. So divide by x square. So this is log a into log b, which is log of a square upon 1. Now you may ask me, sir, can we write a raised to 2x minus 1 upon 2x into 2? Yes, effectively. I'm sorry, effectively it is the same. See, if you do so, then you get log a into log a, that is square of log a into 2. Yes, final answer is this only, right? But here they have written a raised to 2x as what? A square raised to x. So value of this limit is log of a square, but log of m raised to n is n log n. Log a is not 2 log a, it is square of log a. So 2 log a bracket square is the final answer. Sum number 11. Let L be the limit. Limit extends to a sin x minus sin a upon x minus a. Usually what we do, if x tends to a not equal to 0 and standard trigo limit is to be used, then we have to put x equal to a plus h. As x tends to a, h will tend to 0. Yes, this method can be used here. But here I'll tell you shortcut method. I hope you won't say take a sign common. And if you do so, then I think you have no right to learn calculus. Some students say, oh, that was silly mistake. No, it is more than a Himalayan blunder. So please don't do that. What is sin x minus sin a? 2 cos of x plus a by 2 into sin of x minus a by 2. Angle must be fully repeated. So again 1 by 2. Now 2 into 1 by 2 is 1. Next step, limit of product is product of limits. Now to take the limit means to replace every x by its limiting value, which is a. So cos of a plus a by 2. Can I write directly 1 for this? Yes, of course I have to mention the reason for that. All the three conditions are satisfied. Angle is in radian. Now you will ask me, why not in degree? In calculus, it is customary not to mention the unit of an angle if it is radian. In calculus, it is customary not to mention the base of logarithm if it is e, right? So clearly angle is in radian. Angle tends to 0 because as x tends to a, angle tends to a minus a by 2, that is 0. And angle is fully repeated in the denominator. So value of this limit is 1. So the final answer, it is nothing but cos. Right up. I will say as x tends to a, x minus a upon 2 tends to 0. Use another variable. Will give chance to say y now. Okay, so value of this limit is 1. Yes, right up. Sum number 12, let L be the limit. Limit extends to 2 log x minus log 2 upon x minus 2. I hope you won't take log common to get log in bracket x minus 2. That is ridiculous. You have to put x equal to 2 plus h. As x tends to 2, h will tend to 0. So limit h tends to 0. Log of 2 plus h minus log 2 upon h. So basically it is 1 upon h into log m minus log n is log of m upon n. What is n log n? Log of m raised to n. Now I have to use which theorem? Limit of composite function. Limit of log is basically log of limit. So limit h tends to 0, 1 plus h upon 2 raised to 1 upon h. See, you have to mention all the steps. Then only you will get full marks. Okay. Now, same logic. Something is added to 1. Same thing tends to 0. Index must be reciprocal of this. So required index is 2 by h. So first we write what we want, but then we must obtain what is there. And therefore, in the next step, see what I'm doing. I have to use one more bracket here. Limit h tends to 0, 1 plus h by 2 raised to 2 by h to get the original index back raised to 1 by 2. Okay. Now this is standard limit. Its value is e. So log of e raised to half, which is half log e. Now base of logarithm is e only. Log of any number to the same base is 1, provided it is valid. Otherwise you will say, sir, log 1 to the base 1 is 1. Wrong. Base of logarithm cannot be 1. Base has to be greater than 0, not equal to 1. So half into 1. So what is the final answer? It is nothing but 1 by 2. You have to say as h tends to 0, h by 2 also tends to 0, and limit y tends to 0, 1 plus y raised to 1 upon y is nothing but e. In fact, for CET, I'll show you the previous part. Just wait for a minute. For CET, you can remember this as standard result. Which one? Limit x tends to a log x minus log a upon x minus a is nothing but 1 upon a. Okay. So when I say log a, it clearly shows, means that a is greater than 0. Right now. Sum number 13. L be the limit x tends to 1, ab raised to x minus a raised to x b upon x square minus 1. Factors are x minus 1, x plus 1. Actually, you can take ab common. I'm not saying, here I haven't written that, but you could have taken ab common here only to get ab into in bracket b raised to x minus 1 minus a raised to x minus 1, right? But then the same thing. I have put x equal to 1 plus h. As x tends to 1, h will tend to 0. Use laws of indices. What is b raised to 1 plus h? It is b into b raised to h. What is a raised to 1 plus h? A into a raised to h. Take ab common to get what? Limit h tends to 0. Take ab common to get b raised to h minus a raised to h. Okay. Upon h into 2 plus h. Now AB is constant. You can write this outside the limit. So this is AB. Observe this step. Limit h tends to 0. I write this as b raised to h minus 1 minus in bracket a raised to h minus 1. Now you will ask me, sir, how can we know this? The reason for this step is common sense. See, standard function is a raised to x minus 1. This is the reason. H into 2 plus h. Okay. So next step is this is nothing but AB into limit h tends to 0. See what I'm doing? Limit of this part can be taken into limit h tends to 0. Here split numerator b raised to h minus 1 upon h, make use of bracket, right? Minus a raised to h minus 1 upon h. As I have written this part separately, that is why I can take the limit of first part. To take the limit means to replace every h by 0. Here, what is limit of difference? Difference of limits. So limit h tends to 0, b raised to h minus 1 upon h minus limit h tends to 0, a raised to h minus 1 upon h. Okay. So what is the next step? It is nothing but ab upon 2 into in bracket log b minus log a. So final answer is ab upon 2 log of b upon a. Right. 14th is for homework. This is the answer. 15th sum is also for homework. Okay. In 15th sum, you have to divide numerator and denominator by x raised to 5. Now sum number 16. Let L be the limit. Limit extends to a x cos a minus a cos x upon x minus a. You have to put x equal to a plus h. As x tends to a, h will tend to 0. So L equal to limit h tends to 0, a plus h cos a minus a cos of a plus h. So this is a cos a plus h cos a. I hope you won't say a cos a minus a cos h. Now next step, you have to use common sense. H cos a is written first. Don't cancel h in this step. You have to first split the numerator and then only you can cancel that. I have taken minus a common from first and third terms to get in bracket cos of a plus h minus cos a. Now split numerator, then cancel h for the first limit. Of course, you have to say limit of difference is difference of limits. Here what should be done? Use cos a minus cos b. What is cos a minus cos b? Minus 2 sine of first plus second by 2 into sine of first minus second by 2. So split numerator. Now what is cos a minus cos b? Minus 2 sine of a plus b by 2 into sine of a minus b by 2. Next step, limit of difference is difference of limits. Now you'll ask me, sir, why plus then? Because minus minus plus. Okay. Now let me explain. You may think that h square is required. No. If you take limit for this part, you won't get 0. You get 2a plus 0 by 2, that is sine a. So this term, this sine term does not require anything in the denominator, but this does. Note that angle must be fully repeated. So though it is h, I write h by 2, right? So I multiply by 1 by 2. So in the next step, see what I'm doing. Let me cancel h first. I will mention the reason also. H only tends to 0. H is not equal to 0. So limit h tends to 0 of cos a, which is purely a constant, plus now this 2 and this 1 by 2. So it is just 1, but a is constant. I will write it outside the limit. Limit of product is product of limits. So a into limit h tends to 0. Sine of 2a plus h upon 2 into limit h tends to 0 sine h by 2. Please write that angle in a bracket. Make it as rule. If the angle is a fractional angle, then you have to put that angle in a bracket. Okay. So next step, this is cos a plus a into sine of 2a plus 0 upon 2 into 1. So what is the final answer? Final answer is cos a plus a sine a. For that, of course, you have to mention the reason. As h tends to 0, h by 2 tends to 0, and limit y tends to 0, sine y upon y is nothing but 1. Okay. So cos a plus a sine a is the final answer. Now this is the last sum. 17th one. Let me explain. Just listen to me. Limit extends to pi by 4 square of sin x minus cos x upon root 2 minus sin x minus cos x. We cannot take limit in the first step as we get 0 by 0 form. Put x equal to pi by 4 plus h. As x tends to pi by 4, h will tend to 0. Here sin x minus cos x is obtained separately. use sine of alpha plus beta, cos of alpha plus beta, and so on. So on simplification, you get 2 upon root 2 sin h. This 2 is root 2 root 2. So effectively it is root 2 sin h. Okay. See. And what is square of sin x minus cos x then? 2 sin square h. Now this part is again obtained separately to get root 2 into 1 minus cos h. Same logic. So this becomes limit h tends to 0, 2 sin square h upon root 2 into 1 minus cos h. What is difficult? Limits? No. Trigonometry. What is sin square h? 1 minus cos square h. What are the factors? 1 minus cos, 1 plus cos. Can I cancel 1 minus cos? Yes, I can. Because h only tends to 0, h is not equal to 0. Now some students ask me, sir, cos 2 pi is also 0. So if you say h is not equal to 0, we agree. But what if h is 2 pi? This logic is incorrect because when we say h tends to 0, it is almost 0, very close to 0. So how can it be 2 pi, right? And that is why we can cancel this to get this. Now take the limit means to replace every h by its limiting value, which is 0. Cos 0 is 1. So final answer is 2 root 2.